Okay, guys, today we're going to talk about solving systems of inequalities. When we solve a system of inequalities, is very similar to when we graph regular inequalities. So, the solution to a system of inequalities is the region where both inequalities are shaded, so not just one. This past week in our warm ups, we've been talking about inequality, so hopefully this refreshes your memory. Okay, so again, it's just like that, except we're doing two on one grid. All right, and our solution set for the system is just where both of them are being shaded. We can also use a graphing calculator, plugging it into y equals, and then changing our inequality signs. So as long as we don't forget the dashed lines is less than or greater than, solid line is less than or equal to, greater than or equal to. So let's start with this first example here. All right, where we want to find the solution set for y is less than 2 minus x and y is greater than x plus 4. So what we're going to do is, of course, go ahead with our y-intercept here, which is 2. Our slope is -1, so we'll do down 1, right 1, right, to put some points on the graph. And after we do that a couple of times, hopefully we note what our graph is. Remember, this is going to be a dashed line. So I'll put a few more points to make sure I'm on the right track here. All right, so dashed line here. All right, there's my dashed line. And since this is less than, right, we're just going to shade below. Do some shading below, right? For the next one, I'm going to use a different color here. When we graph y is greater than x plus 4, don't forget we start at the 4. And then we go up 1, right 1, since the slope is 1, right? And remember, we can do this in the calculator. I'm just doing it by hand. And then dash lines. And since this is greater than, we shade above. All right. So then the question becomes, where, in what region of this graph is both inequalities being shaded? Is it in this little region here, right? In this little region, this region, this little region, or this region? And hopefully we see it's this region where they're both being shaded. So I'm making it dark, right? And then from here, we're going to do the next example. All right. Let's say we have y is less than or equal to -5 over 2x minus 2, right? So with this, we start at -2. And we're going to go down 5, right 2. Or we can go up 5, left 2. And don't forget that this is going to be a solid line because of the equal to part. So something like that. Because it's less than or equal to, we're going to shade below, right? Then we're going to get another color, start at 2, and then go down 1, right 2. Or we can go up 1, left 2. Right? This is going to be a dashed line because it's just less than. And because it's less than, we shade below. Now the question remains the same. It might look a little confusing, but it's divided into regions, right? This is a region right here. Is this where both inequalities are being shaded? Is this where both inequalities are being shaded? Is this where both inequalities are being shaded? Or is this where both inequalities are being shaded? And this is our answer right here. So we're going to kind of darken that to make sure we note this is what we want right up in here. All right, even if you want to take another color and just go in on it so we can make sure we know this is it. That's our shaded region. All right, now when we get to this next problem, we got to remember the whole, since this is in standard form, we got to do the whole parentheses minus 4x, close parentheses, divided by negative 3. But realizing by dividing by negative 3, this inequality sign has to change to greater than. All right, same thing here, except this isn't a minus sign, so we don't really have to worry about changing this inequality sign. All right, I suggest we plug this in the calculator into y equals. All right, or just simplify, right? 2 divided by x and 2 divided by negative 6, and then graph it up here. All right, it's all up to you. We're going to finish this in class, and then we're going to do IXL T6.